Hello and welcome to Innovations on QFRadio. I'm Scott Boyce, and every week we bring you exciting discussions about the latest scientific, technological, and environmental advancements making the headlines. As always, we want to hear what you have to say about anything we discuss on the program. So give us a call at 4454-1010. You can tell us what you think on our Facebook page or follow us on Twitter at QFRadio, or you can follow me at Scotty Boyes. That's Scotty with two T's and a Y, B-O-Y-E-S. We have a very special episode planned for today. I'm actually genuinely excited about it. You may not have noticed, or maybe you noticed and everyone just thinks you're a little crazy, but robots are taking over our lives. They are doing just about everything that we as humans can't or simply don't want to do. The age of robotics has long been something we read about in science fiction novels. But faster, more powerful computers, smaller parts, and some very, very creative and innovative people have helped usher in some incredible technology that is changing the way we live and work. The topic is really much bigger than we even have time to scrape the surface of on this program. When I decided to talk about the subject, I honestly had no idea what I was getting myself into. It is huge, it is complex, and it is even deeply philosophical. So, we've tried to break it down and present the topic as simply as possible. First, we'll be speaking with Rob Buckingham from OC Robotics. His company creates some remarkable technology that is helping commercial industry go places and do things that people simply can't. But their robots are designed to do exactly what they're told. What happens when you give robots a mind of their own? Artificial intelligence is a field that explores the ability of computers to think for themselves and behave like humans. Where do we stand with AI today? What are the questions we're asking to better understand what it means to be human and to think for ourselves? Dr. Mark Bishop, professor of cognitive computing from Goldsmiths University in London, will join us to answer some of these questions. The robotics industry has been growing exponentially, but don't let this scare you. If you want to get into the field yourself, there are some great resources out there to help you get started and learn how it all works from the ground up. Dr. Bina Ahmed from Texas A&M University here in Qatar will join us to explain how you can build your own robot, where to learn more about it, and what you need to put yourself in the best position to make it your career. We're going to take a very quick break, but when we come back, we'll be speaking with Rob Buckingham from OC Robotics about some of the very real robots they're making right now.
We're gonna miss the good old days.
What good old days?
When people were killed by other people.
My robots don't kill people.
That thing threw somebody out of a window. Is that registering with you?
A robot cannot harm a human being. The first law of robotics.
Yeah, I know. The 3 laws. You're in perfect circle of protection. What if it was given in order to kill? That's impossible. It's a can opener, for God's sake.
You're not suggesting that this robot be charged with homicide.
Just another normal day, attacked by your robots.
Well, I suspect you simply don't like their kind.
We are on the eve of the largest robotic distribution in history. By Saturday, there will be one robot to every 5 humans.
How many robots have ever committed a crime? How many robots in the world?
None.
There is no conspiracy. What this is one mistake.
Somehow, I told you so, just doesn't quite say it.
Get off my car!
That was, of course, a clip from the trailer for I, Robot, starring Will Smith, that came out in 2004. As I mentioned at the top of the hour, we're talking about robotics today. Simply put, robots are machines that are capable of carrying out a task or series of tasks automatically. Now, we are a long way from a robot uprising as seen in that film, and I thought the best way to introduce the subject and put in perspective what actual robots are capable of was to separate what we see in the cinema with what the industry is creating for very real, very practical purposes. And the best way to do that was to speak with someone who can give us a realistic idea of what it takes to bring cutting-edge products like this to market, what obstacles they face moving the technology forward, and where the industry might be in the next 10 years. Joining us by phone to explain all of this is Rob Buckingham. He is the co-founder and managing director of OC Robotics out of Bristol in the UK. Rob, welcome to the show.
Thank you for having me.
Can you tell us a little bit about yourself, OC Robotics, and what your mission is as a company?
Okay, I've been interested in robotics since I was a kid, and Andrew Graham and I set up OC Robotics about 10 years ago now. And what we're doing is focusing on a new niche market, which is confined and hazardous spaces. And we've developed a range of robots that actually get into those confined and hazardous spaces.
Robotics as a concept has been around since even the days before steam engines. For hundreds of years, people have been imagining the potential applications for machines that do the work we're unable to do as humans. Yeah, we were promised flying cars, and we still haven't seen them. It's only recently that we've begun to see the futuristic dreams sort of begin to take shape. What have been the obstacles to those ideas becoming reality? What has changed in the last 10 years that contributed to the explosion of robotic technology?
I think probably the biggest change that's been happening in the background is the rise of computing power and memory. And what we've realized is that humans do amazing things. Human beings are unbelievably good at sensing their environment and then doing things, making decisions. And what we've been finding is that actually to replicate any of that is very difficult. We're all used to cars that are built by robots. And when you think about the robot, actually it's a very simple device. It's not really having to do very much. But if you try to then apply robots into, let's say, a kitchen or a room which has got a baby crawling around and an old lady or someone with dementia, that gets immensely difficult very, very rapidly. So actually, I think it's the thinking bit, the decision-making bit, which has really held back robotics. And by the same measure, what's happening is that people are slowly making progress and focusing on what I would call industrial tasks, rather than going full on for robots wandering around homes and doing things in human spaces.
OC Robotics primarily develops what are called snake arm robots for, like you said, use in confined spaces. Now, a natural extension of that, as I would see it, is surgery for use inside the human body. I was reading in the BBC that you recently showcased a robotic arm for exactly that purpose at the International Conference on Oncological Engineering. Can you tell us a little bit about this technology? What does the product do? What's its purpose? How does it work?
So what we've been thinking is, could we apply the same sort of technology that we use for our big robot arms that get into, say, a nuclear reactor or a big industrial machine? Could we actually shrink that down and make it small enough that it could work within the human body? And what we've come up with as a very early prototype is what we would call a steerable endoscope. At the moment, endoscopes are pretty floppy. They don't really go where you want them to go because they're always fighting gravity. So we're looking at whether we can make a stiff, steerable endoscope that can actually navigate within the human body and go to places from just one entry point.
And I've seen this thing in a picture, and I have to say it's pretty creepy. It looks like it's right out of a science fiction film. On the end of it, it's got sort of claws, and it looks like tools on there. What's it supposed to do inside, or is it pretty general use?
So we have to make it general because one of the key things with surgery is that you've got to be cost effective. So we need to make a piece of equipment usable for a whole range of different tasks. And our approach so far is to think about this thing as a way of getting the surgeon's hands effectively into the human body. So what we're trying to do is make it so that the surgeon feels as if his or her hands are inside the body and they've got tools in those hands, little ones, that are doing fiddly things. And so the role of the snake is actually to navigate to these places. And so we developed some software that allows the nose of the snake to lead and the rest of the body follows. So we call that nose following.
And the tools on the end there, I saw there's like a gripper and there's probably a camera on there. Is that correct?
Yeah, and those things are routinely used every day of the week in laparoscopic surgery, and they've been around for a long time. So things are getting smaller, but those sorts of techniques are routinely used. So what we're trying to do is just make the surgeon's experience better, and therefore hopefully the surgeon will do things faster. And of course, patient outcomes have to be the key driver for this. So we're aiming to make patient outcomes better and also reduce the amount of time people have to stay in hospital.
Why is the field of medical robotics, robotic surgery, so attractive? Why aren't we seeing this kind of progress in, say, robots that clean my house? What's the difference between the two?
I still think that the human body is slightly less random than my house, as an example. I mean, houses and offices change so much. At least you know roughly where things are inside the human body. But I think the other big thing is that actually everybody is very interested in their own health. And so it's a big market, and we want the latest technology that will keep us well. So it's all about our standard of living and quality of life. And if any tool comes along which is affordable, which increases our quality of life, of course we're going to jump at it. So yes, it's a very important sector for all of us. And also we're finding that companies are making progress and they're doing well.
Where do you see either the medical applications of robotics or robotics as an industry going in the next 10 years? I guess what I'm getting at is, are the obstacles that we discussed previously still valid moving forward, or are you struggling with new ones that you never would have expected?
No, I think we're still struggling with those old problems of being able to cope with variability, making systems that are really robust and reliable. You always have the challenges of materials that are okay for use inside the body and those sorts of things. And of course, there are always the commercial challenges. Does it make sense to invest the vast amounts of money to develop these systems?
So a pretty logical answer is that we don't see the robots cleaning our house because there really isn't a lot of investment in that sort of technology, whereas in medicine, this is a lot more practical. Is that accurate?
I think in the surgical space, there are already some successful companies. And so that is very appealing for investors who will say, is this very high risk or not? An investor wants to see a return. And those returns are there. People have benefited greatly from developments in medical devices over the decades. I think it's still early days for robots in the home, and it's going to be some brave people with some deep pockets who push the advances forward. But we have got a number of companies who are starting to do some very interesting things, mostly in America. But those other companies in other parts of the world will be releasing hardware, I'm sure, over the next few years, which will probably astound us.
Now, artificial intelligence, it seems to be developing on a completely separate track than the engineering of machines. Instead of, I think, coexisting as many people thought it would. Do you see AI as a natural evolution of the industry? Will these two begin to converge, or has it already?
Our view of artificial intelligence is that it's great if it improves the performance of the machines that we make. So we have a very pragmatic approach. We'll use advanced software where it makes sense and it doesn't cost too much. So actually we do some fancy things in terms of how to control our robots. Are they artificial intelligence? In a sense, it doesn't matter what you call them. They're pieces of software that enable us to do things better and faster. So I think there is a link. But we're not going to be seeing, robots wandering around our streets in the next few years. It's going to take a lot of time before we get to, the iRobot Hollywood style of robot.
Sir, you've been really great. Is there anything that I may have missed here that you feel it's important for people to understand about the robotics industry?
Well, I suppose it is very important to distinguish between science fiction and CGI graphics, and actually building equipment, building hardware which achieves a function and doesn't cost too much so that it is affordable. So those are the challenges that we face. We're not going to keep up with science fiction. We hope that science fiction will stay ahead.
Trying to get people to distinguish between what is practical and what can actually end up on the shelves and what can't is a great way to end it. Rob, I really appreciate your time. Thank you so much for coming on the show.
Oh, that's a pleasure. It's great to contribute to these things. Robots are coming. There are some wonderful engineering developments that are happening all over the place. This is a very ripe area to be working in, and it's great fun. Any young people out there who want to do something fun in their lives, then go and get a robotics degree.
Thank you, sir, for coming on the show.
Thank you.
We're going to take a very quick break, but when we come back, we'll be talking about the current state and future of artificial intelligence. Don't go away. Welcome back to Innovations on QFRadio 93.7 FM. If you'd like to get in touch, give us a call. We're at 4454-1010. Check us out on our Facebook page or follow us on Twitter at QFRadio. But I'd actually like it if you'd follow me. We're having sort of a competition around here and I'm losing horribly. I am at Scotty Boys. That's Scotty with 2 T's and a Y, Boyes. Artificial intelligence sounds scary. To a lot of people, I think the thought of a machine being able to think and behave like a human is a threatening prospect. Will computers someday be able to blend in so well that we're unable to distinguish something alive from something manufactured? Is a software program capable of writing a song or a poem? What about consciousness? Will a robot ever have the ability to know it is alive? We are certainly not there yet, but the field of artificial intelligence is continuing to evolve and push these seemingly inevitable eventualities forward. When I invited our next guest to come on the program, I don't think I had any idea how big the questions were that I was asking. Artificial intelligence is part science, part engineering, part psychology, and even part philosophy. Here to help us wrap our brains around what this all means is Professor Mark Bishop. He is the chair of the UK Society for the Study of Artificial Intelligence and Simulation of Behavior, while also a professor of cognitive computing at Goldsmiths University, London. Professor Bishop, welcome to the show, sir.
Hi.
If we can start very simply here, because this is a very big topic. In a nutshell, can you tell us what is artificial intelligence?
It's a very big question, but in simple terms, I like to think of artificial intelligence as the science and engineering that's involved to get machines to do tasks that if they were carried out by a human, we would say would involve intelligence. Now, the kind of tasks I'm thinking of are things that might range from, say, recognizing a face, understanding a language, driving a car, or playing chess. And one of the strange things about artificial intelligence is that some of the tasks that we paradigmatically might think are the ones that most strongly involve intelligence. Many people would say playing a really strong game of chess involves huge amounts of brain power, and only a small number of humans are able to do that very well, whereas tasks like understanding a language or recognizing a face, virtually all small children from 4 or 5 upwards around the world can do with ease. One of the strange things about AI, tasks that we've historically imagined involve lots of intelligence, like playing chess, we managed to get machines to be able to do that many years ago. Machines can play very, very well. In fact, IBM's Deep Blue chess-playing computer managed to beat the best human chess player that's ever lived, Garry Kasparov, many years ago now. Whereas those tasks that we sort of think don't involve much intelligence, like understanding language or recognizing faces, have proven really resilient to getting computers to do them very well.
What common things do we see today that employ possibly the simplest concepts of artificial intelligence?
Well, one of the nice things about being involved in artificial intelligence at this point in time is that we're beginning to see artifacts that embody ideas from artificial intelligence creep into our everyday lives. And many people now around the developed world have access to devices like washing machines. And they often use artificial intelligence to monitor the water temperature, the machine load, whether the person wants to wash woolen clothes, linen, delicate clothes, etc. And these AI programs will then use that information to get the best wash cycle that's possible. We also see AI programs involved in household robotics. Perhaps not all your listeners may be aware that many people now are able to buy robots that they can use in their own homes and gardens. In fact, there is a machine that you can buy off the shelf now that will clean floors for you, a robot floor cleaner. And this embodies artificial intelligence to move around the rooms in your house, to sense where the walls are, to sense what type of floor it has to clean, whether it's hardwood or tile or whatever, and clean appropriately, to avoid knocking into plants and furniture or pet animals, or for that matter, little babies, and do all those complicated things and yet still clean your floor efficiently. Some of your listeners may have access to modern mobile phones. I'm thinking now of the iPhone, the Apple iPhone devices, and since the iPhone 4S, these devices have some software in that's called a Siri interface. And this is a truly astonishing piece of software, artificial intelligence software, that you can actually speak to command your phone to do all sorts of interesting things and useful things, like book appointments in your diary or answer simple questions. You can do all these things just by speaking in your natural language into your phone. So that's just a few examples of AI as it's reached out and is in more and more people's everyday world.
I think those are both great examples. You have on one side things like washing machines that people might not assume are using the same sort of technology, artificial intelligence, and then on the other, something like Siri, where it's able to understand what you're saying and then be able to react accordingly. Is that right?
Yeah.
Okay. I have done a little research on AI, and I have heard that the study is often defined as two basic factors: control and perception. Now, I'm hoping you're going to correct me because this seems a little simplistic. It sounds like this would apply really only to those machines that are given specific instructions. Make my coffee, clean the house. They need the ability to control themselves in such a way that allows them to physically complete the task, but they also need the ability to perceive what's around them. For example, not running into tables. If we want them to behave autonomously and think for themselves, isn't there a lot more involved here? I mean, I'm thinking logic and common sense. Does it really just come down to those two factors, control and perception?
Well, you picked on a favourite topic of mine, and we can talk for hours on this particular topic. I strongly believe, I think, in line with you, that there's a lot more to intelligent systems than just control and perception. And in fact, ever since the discipline first began studied, there's been a debate raging between two different sort of factions within the discipline. There have been critics of artificial intelligence, and one of the earliest critics of artificial intelligence was a guy called Hubert Dreyfus, who wrote a book many, many years ago now called What Computers Can and Cannot Do. And he was arguing against some of the grandiose claims that were coming out of the early AI labs from people like Marvin Minsky, people like Frank Rosenblatt. Rosenblatt, with his work on a device called the perceptron in the early 60s, famously said, here we have a machine for the first time that thinks for itself. And this was a machine that was powered by what we would now call neural networks, which are very, very crude simulations of how brain neurons operate. And Rosenblatt built some really early neural network systems in the early 60s that were able to recognize simple shapes and things. And Rosenblatt was saying, yes, with these devices, these perceptrons, we have machines that can really think for themselves. Approaching the technology from a totally different angle, Marvin Minsky, who in his later life certainly was most associated with symbolic artificial intelligence, again began to make strong claims about what could be achieved using strong artificial intelligence principles, the ideas of heuristics and symbol search. And Dreyfus looked at what these guys were achieving and said, hang on a minute, there's an awful lot more to a human intelligence than just recognizing simple patterns like Rosenblatt's perceptron was able to do, or following very complex rules like the sorts of systems that Minsky was interested in at the time. And in particular, Dreyfus said we've got to be able to think, machines got to have something like common sense, not just the ability to follow rules rigorously, doing the same thing every time. But there's a certain sort of nuanced behavior about humans that we know when common sense says, don't just follow the rules, do something outside the box. How are you going to get a machine to do that, Dreyfus was saying. And I guess I have a lot of sympathy with Dreyfus's critique in this book, what computers can and cannot do. And one of the ironies of my position in that I chair the Society for Artificial Intelligence is that actually deep down I'm a kind of a skeptic about what machines can really ever be able to do. And in fact, my own view, for what it's worth, and I can't speak now for all the members of our society because some of them will not agree with this, but my own view is that we may be able to in time get machines that can simulate aspects of human intelligent behavior, that can look as though they're behaving intelligently. But these machines, when push comes to shove, really won't be exercising that intelligence in anything like the way that humans can. For example, a machine might be able to look as though it's counting apples on a fruit packing production line, but that machine really, although it might be able to count the apples very, very accurately, won't really know that it's counting apples as opposed to bananas, pineapples, or car engines. So I think there are fundamental limits, as far as I can see, about what can be achieved by electronic computational devices following stored programs.
Well, I'm glad that it wasn't just me that had a problem with sort of distilling down the human existence to those two things, because to me it seems a lot more complicated, that I'm using more than just control and perception. So it makes me extremely happy to hear that that is a current debate within the field. But what about, and you touched on this for a second, but what about self-awareness? Would you say that a consciousness is a requirement to reach the full potential of AI? Do machines ultimately need to be aware that they exist and have a sense of preserving their own survival, or is that not really necessary?
These are very beautiful questions you're asking, and there's a lot I'd like to say on this particular one. But I think before we address this question, there's just a couple of extra additional points I need to raise in respect of your last question. And in particular, I'd like to highlight one of the big problems that's been facing AI for a long time. And some people would claim that in part it's now solved. I'm not completely convinced. I don't think anybody around the world would say this problem is completely solved. But I just want to outline one of the big problems that really brings into focus, I think, the difference between humans and machines when we're problem solving. The problem goes by the name of the frame problem. And what this means is, how do we get machines to ignore what doesn't matter when we want the machine to do something useful? This problem was really brought to the fore by an excellent paper by the American philosopher Daniel Dennett entitled The Frame Problem, Cognitive Wheels and Artificial Intelligence. And at the beginning of this paper, Dennett paints the following thought experiment. He says, imagine that there is a robot in a room, and in the room there is a bomb, and the bomb is on a trolley, and also on the trolley is a power supply, and the robot's power supply is going down. The robot knows it needs to get some more power, so the robot goes and pulls the trolley out of the room. Well, what do you think happens to the robot then?
He's killed by the bomb.
That's right. The robot didn't foresee that bringing the unintended consequence of its action in retrieving the trolley with the power supply was it was also bringing the bomb out of the room with it. So the designers of the robot thought, oh my God, what are we going to do to help resolve this? We're going to have to get the robot to think about the consequences of its actions. So they then designed a new robot, and this is going to be called the robot deducer. It's going to deduce the consequences of all its actions. And the robot's put in the room, and the designers are watching to see what happens. And now the robot sits in this room and it looks at this delicious power supply that it needs to get to continue functioning. And it thinks to itself, well, if I pull the trolley out of the room, the walls won't change colour. If I pull the trolley out of the room, the carpet on the floor will remain the same. If I pull the trolley out of the room, the day will remain Monday, etc., etc. And as the robot's doing all these things, working out the consequences of what will happen, what happens next? Well, of course, the bomb explodes because the robot's just sitting there doing nothing, working out all these ridiculous consequences. So the designers then go back to the drawing board and think, what we've got to do is, it's not for the robot just to think of all the consequences of what will happen. It's got to just think about what are the relevant consequences. So we design a new robot, the relevant deducer, and they let this robot on the same problem. So the robot goes into the room, sees the trolley with the bomb and the power supply, and now it thinks to itself, well, if I pull the trolley out of the room, the walls will still stay the same colour, but that's not relevant to my problem. So I'll put that on a pile of propositions which are called irrelevances. And I'll think of the next thing. If I pull the trolley out of the room, the day will still stay Monday. Well, that's obviously an irrelevant proposition. And it goes on sorting out all the things it can think about into relevant and irrelevant propositions. And again, it gets nothing done, and eventually the bomb blows up and the robot is destroyed. And this problem really brings to the fore something beautiful about human intelligent problem solving. We have an ability as humans to hone in on what's relevant to solving particular problems. We have this ability to just think about the issues that matter to try and help us solve the particular task we have in mind. And trying to get computers to do that, to only think about things that matter, is incredibly difficult. It's been a really difficult problem for computers to solve. And you might think of it as a problem to do with search. If you think about the previous example of the robot in the room, in one sense what the robot was doing was searching through all the possible actions and consequences that it could entail and trying to find the best set of actions that will lead to its own survival. That, we say in computing terms, is something that we call the search problem. How can we search through and find the best set of propositions that will solve the task in hand, and how can we do that really, really quickly? Now, of course, in the examples I painted, the robot was doing what we in computer science say is something called an exhaustive search. It was laboriously going through every possible concept to try and find the ones that help the robot solve the problem. And of course, humans don't do that. We have this ability to just hone in on interesting concepts. So how do we get computers to solve problems efficiently without doing this exhaustive search? And it's really, really difficult. And basically, there's really only two ways you can do this. When you do problem solving, you can either do it exhaustively, which involves huge amounts of computer memory and really, really fast microprocessors. And even then, there might be some problems like playing the perfect chess that's just pretty well impossible to do by exhaustive search. Or you can do something called heuristic search. And what that means is trying to embody shortcuts in your reasoning for particular problems. So you try to hard code, if you like, aspects of human knowledge that mean the robot doesn't have to search through every possible concept to try and get to an answer. But by making your system embody hard knowledge in this way, unfortunately the downturn in doing that is you often make AI systems that are very, very brittle. And what I mean by that is it's systems that will break down very, very, very easily. So intelligent problem solving is something that's been concerning philosophers and computer scientists for a very, very, very long time. The naive way of doing this, solving this problem by exhaustive search, just is too impractical. The kind of the shortcut why you've been doing this for the last 40 or 50 years in real engineering systems, using these heuristic searches, by doing shortcuts can tend to make the resulting engineering systems a little bit brittle. So modern AI is trying to sort of resolve these two competing pressures, how to solve problems really well and get really good intelligent solutions to a problem without having to do full exhaustive search and without encoding too much problem-specific knowledge to the computer program. So, yeah, that's like an addendum to the last question you asked.
Well,
I wonder whether you'd like to ask me the question about consciousness again now.
I think that sort of embodies what that next question is. Would you say that a consciousness is a requirement to reach the full potential of AI?
I personally think we do need something like consciousness to get real, genuine AI. because it seems to me if we don't have something like consciousness in an artificial system, it's very difficult for that system to have true goal-directed behavior for that system. Without something like consciousness, any behavior of the system is kind of engineered into it. It's not a system that's behavior that's emergent from the system itself. And it's really difficult to see how we would go about building machines that really are intelligent and we can really say do things for themselves without having some access to conscious states, some access to something akin to pleasure and pain, because without these notions and without the experience of things like pleasure and pain, it's really difficult for me to see how a machine can ever ground itself in the human lived world. And without access to these notions, it's really difficult to see how a machine could ever genuinely understand anything. So I'm very sympathetic to the notion that if a computer is ever really going to understand anything, then it's going to need something like consciousness. And unfortunately, I don't see that there are any good grounds for believing that the mere execution of a computer program will ever be enough to instantiate consciousness in a machine. And therefore, I have some skepticism whether machines ever genuinely will be able to understand anything, whether at best machines will just be able to appear as if they understand something.
I would almost tend to agree, because it seems as though computer programs at this point are largely two-dimensional, and the problems that we're looking to solve exist sort of in another almost three-dimensional way, that the current approach that we have to computers and programming, it's simply not compatible with the types of abilities that we're talking about here. For example, just trying to, as the example you gave before, where you want to eliminate all possibilities, such as the bomb going off, these exhaustive searches. It almost seems like the framework that we have for computers and software today do not have the ultimate capability to do what we're talking about. Is that accurate?
That's pretty well, in a nutshell, my own position. Now, again, I've got to be careful here in that you introduced me in my role as the chair of the UK Society for AI and the Simulation of Behaviour. And I think many of my colleagues in this society might take a different view on these subjects. So I'm speaking now in my own capacity, in a personal capacity, rather than suggesting I'm reflecting the view of all our members. This is kind of a current hot topic in the subject, and there will be different views. Some people might hold different views, but the position you're espousing is certainly one I'm sympathetic to. I think we've really got to look a bit deeper about what really drives things like human creativity and human intelligence, and get a better handle on that before we can really begin to make claims about instantiating these properties in machines. And I think we're a long way from doing that at the moment.
As you mentioned before, this is a huge topic that we can only begin to break the surface on. But you just mentioned creativity. Can a machine, a computer, be inspired? Can it paint a masterpiece, write a symphony? I guess it starts with the basic question, what is creativity?
A really interesting question. This idea about whether a computer can ever genuinely be creative is a question that's been asked since before the birth of electronic computers. In fact, before the birth of even mechanical computers, the question was there. And it's an issue that I've thought about and published about myself, together with one of my recent grad students, a guy called Mohammed Majid Al-Rifai. One of our recent papers was entitled Creativity and Autonomy in Swarm Intelligent Systems, and this was published in the Cognitive Computation Journal just this year, and it's on these very issues. And obviously a lot of people around the world are interested in these issues, because this particular paper has been the most downloaded paper for that journal for the last 2 or 3 months. And one of the things we talk about is a notion of whether you can have a weakly creative computational system, that you might design a system that just appears to, in some sense, exhibit some kind of creativity, that using the system might actually give us some insight, be useful to help us understand better the notion of creativity in real humans. And then we contrast that with a notion of strongly computational creative systems, and these are systems that, if they exist, would be systems that you could genuinely say are creative in their own right. Now, you might gather from my earlier answers to your questions that I'm kind of more sympathetic to the notion of weakly creative computational systems. Nevertheless, to be fair to my members in the society, there are many people who do believe that computers can genuinely be creative, and I'm thinking here in particular of a guy called Simon Colton from Imperial College in London, and he's developed a system called the Painting Fool. And why I personally think this program, although I still have reservations about it being creative in a strong sense like a human might be, I think it's a very impressive program, and the reason being is that it's a program for producing visual art. It produces visual art that relates to things that are going on in the world today. Basically, Simon hooked up his Painting Fool to a news feed on the internet, and say if it heard that there was an earthquake in Iran today, this system could then pick out those keywords, earthquake in Iran, and then it would scan the Flickr image libraries for images that related to earthquakes in Iran, and then using the complicated rules about aesthetics that Simon has coded into his program, it's able to make a montage of new images that have never existed before that are about something that's happening now in the world. There's this hypothetical earthquake in Iran, and this computer will generate an artwork that relates to something that's going on in the world. So I think that's a very, very impressive piece of work. Simon is still extending the system as we speak, making it all the more impressive every day. And certainly for people who are interested in the idea that computers can be creative, I strongly recommend you check out Simon's work. Although, as I said, personally speaking, I'm not sure I think it still is creative, genuinely and fully creative in the way that a small child might be when he or she paints a messy image using paints or crayons.
Well, it certainly raises an interesting question. Are we overestimating how complicated our creativity is? Are we, on some basic level, just doing that, just taking images and ideas that come to mind and mashing them together into something that his simple project is doing there? And it certainly seems like it's a matter for a lot of debate. And the example that I'm thinking of is that they have computers now that can analyze music, new music, and then compare that to successful hits from the past, and then make a generally accurate estimate about whether or not that new music will be successful. And I'm just wondering then how far removed we are from that computer then saying, well, I know what's going to be successful. I can write it myself. So it's certainly a huge topic there, and I'd hate to rehash it, but it's interesting that these are the questions that are still being asked among people who are so heavily invested in artificial intelligence.
Well, I think there's 2 points we can raise here. One is computers as they exist now on the planet. That is what they do. At the end of the day, they're controlled rigidly by their computer program. And these computer programs are designed, so a computer will be designed by an engineer to do particular tasks. Now, I suggest to you that's a very different notion, like a second-order notion of creativity. If we build a computer program that appears to be creative, like Simon's Painting Fool, Simon is the guy that's nonetheless created that program to do this particular task. In my opinion, that program no more knows that it's creating images about earthquake in Iran than, say, Neil Armstrong landing on the moon. It doesn't know anything about what it's actually manipulating. It's just binary ones and noughts as far as the computer's concerned. And I think that's a very different notion of creativity than even a very young child has when they, say, try to draw a house or a tree or a landscape with a sun. A child might not be able to execute that drawing very well at the age of 5 or 6, but they know that what they want to depict is a house, an animal, a tree, things like that. They know what they're doing. The child hasn't been programmed to produce works in a certain way. The child is acting under its own free will. So I think, to me, the notion of strong creativity really is very, very tightly interwoven with this other philosophical notion of free will. And it isn't clear to me how a stored program computer can easily instantiate something that's akin to this human notion of free will.
We see innovations like Honda's Osimo, where the technology has focused primarily on creating something that behaves, moves, and acts like a human. Walking upstairs, running, even dancing. When do you see that avenue of research converging with the advancements in artificial intelligence?
To answer that question, we need to go back in time a little bit. In the 1970s and the 60s, the dream of the great scientists around the world who were working in artificial intelligence was to build AI systems that also might shed some light on human intelligence, that might give us some insight as to how humans act intelligently. And unfortunately, all the systems that were built on principles that purported to instantiate or to model extant knowledge about how humans behave intelligently actually didn't work very well in the real world. Now, at the time, the alternative was this kind of exhaustive search metaphor or something akin to it. And in the 60s and 70s, computer power was so relatively limited, computer memory was so relatively limited, that you couldn't do very much by blind, unintelligent search. But of course now, we've got phenomenally powerful computers and massive amounts of computer memory. So it's astonishing now what we can achieve using AI systems that actually don't purport to give any insight whatsoever about the way that humans work, but do lots of dumb things really quickly. So we can get machines now that can purport to classify aspects of images quite accurately. We can get things like Siri that can act as if they understand language very efficiently. But the technologies that underpin these are basically built on having access to huge amounts of data, really fast processors and lots of memory. And using these technologies, we're now getting machines that can, from the outside at least, look as though they're behaving intelligently, even though what they're really doing is actually a little bit kind of dumb and certainly very unhuman-like, but they do these things really quickly. So to come back to your question, I think we're living in now a very exciting time. When Honda developed the Asimo robot, it's an astonishing piece of hardware engineering. As someone who worked for many years in a cybernetics lab, was fundamentally concerned with building robots, I can say that what Honda achieved in the Asimo is, from an engineering perspective, truly amazing. It's a really great piece of hardware. But of course, the software at the time was lagging behind. Your listeners might be able to see, if they go to the web, video of Asimo walking up and down stairs or even dancing. But what they might not know is that Asimo was hard programmed by its engineers to do those particular tasks. It didn't just do them as its own volition. It can't just do them naturally. It has to be individually coded to do these things. But now, the increase in computer power, the increase in computer memory, the access to big data, and these new ideas that are percolating into AI, where people are kind of ditching the idea that to build intelligent systems, we need systems that are going to shed some insight on real human intelligence. We just want systems that are going to work. If it works well, that's all that matters. Just let's throw computer power at it, throw money. These kind of systems are now starting to come to the fore. So I would imagine within the next decade, when the engineers at Honda start taking these ideas of big data, uber-fast computers, and huge memory seriously, we're going to start seeing that Asimo robot do more and more sophisticated things without having to have its engineers reprogram it laboriously for every individual task. In other words, I can foresee in the next 10 or 20 years, people who are wealthy enough be able to have something akin to an Asimo in their own home, interacting with them in a kind of natural kind of way.
And I think we're beginning to see that specifically in Asimo. The latest video I saw, there are people walking and he's able to recognize and avoid obstacles that are walking toward him. Now, that's very simplistic, but it shows, I think, the direction that it's moving, where it's now not simply pre-programmed steps, but it is beginning to, and I hate to bring it back to this, to perceive the world around it and then react accordingly. So I think we're beginning to see them move in that direction, and it's very exciting, because when these two different tracks begin to come together, the products and the technology, I think, will just blow people away.
Exactly. But of course, when we have the idea of robots being widely used in the homes, we're again unfolding a whole new arena of potential ethical problems. For example, what happens if a robot performs an action badly and perhaps injures a human or kills a human? Who is responsible for that? Is it the robot? Is it the manufacturers of the robot? Do we give ethical rights to robots? Would it be wrong to turn them off, for example? All these questions are growing up a big arena of what is called machine ethics, an area of philosophy that is interested in establishing what, if any, ethical rights we can begin to ascribe to machines.
This is so much bigger than I think I ever imagined when I wrote up some of these questions and was deciding what I wanted to ask you. Normally, at the end of the show, I ask if there's anything that I may have missed or glossed over. However, I'm pretty positive that I have probably missed or glossed over more than we were able to cover. So I'll probably just skip that one if that's all right with you, sir.
Absolutely, yeah. It's a huge, the things that we're talking about here are really, really foundational questions. And if anyone looks at my website, they'll see a quote from me saying, I think I'm very lucky in that for me, the boundaries between work and social life are very tenuous because I'm so interested in these questions. They're really foundational issues that really excite me and get me out of bed in the morning, and I think should be of interest to many people around the world.
I know our listeners will certainly be interested. Professor Bishop, thank you so much for coming on the air to speak with us. It was a very enlightening conversation. We really appreciate your time.
Thank you very much for inviting me. It's been a delight to speak to you.
We are almost out of time for this week. Many thanks to all of our guests who joined us. But before we go, I want to leave you with a very quick chat we had with Dr. Bina Ahmed. She's a lecturer of electrical and computer engineering at Texas A&M University here in Qatar, and she's going to tell us how you can get started in robotics if you're interested. This has been Innovations on QFRadio, 93.7 FM. Dr. Bina, welcome to the show.
Thank you very much, Scott.
Can you tell us just a little bit about yourself? What do you do at Texas A&M?
As you said, I'm a faculty in electrical and computer engineering. I teach a number of different courses. One of them is a freshman introductory course on engineering, and I also teach some more senior courses, both at the sophomore and junior level in electrical engineering.
Now, our whole show today has been about robotics and some of the technology that's now involved in some of this. But we'd like to bring it back to something a little more simple. Your intro engineering class, you have them create robotics projects. Is that correct?
Yes, that course is basically aimed at giving students a hands-on introduction into engineering. And robotics offers a very simple but effective experience to engineering because it encompasses a lot of different programs. So there's a mechanical aspect to it. There's a electrical aspect to it. There's a programming or computer science aspect to it. Then obviously there's material science, chemical engineering. And then robotics now, the application of robotics is so widespread in industry, in medicine, in daily use now at some places. So this offers us students with a very good opportunity to understand what engineering is all about.
How can students who are interested in robotics get started within that field? What's a good place to go?
Wow, the options are, limitless now. There are a lot of simple kits that you can buy on the market. For example, there's a soda can bug robot that you can buy. It's only for like 40 reals, $10. And then you can get more advanced kits, and they're kits that are multi-purpose, so you can build different kinds of robots. For example, the most popular is one built by Lego. And so obviously Lego, everybody's familiar with Lego. So you build it with Lego. It's got a little sort of mini computer, you can say, called the NXT, and you can program it. And there are lots of different tools to program it with. Some are very visual, so which assume you have no background in programming, whereas others are more advanced. There are lots of websites now dedicated to robot kits. There's www.robotkits, RobotBuy. There's tons that you can go at. So I would just say go for the first kit that you can find and start building.
What are some of the best projects that you've seen from your students that really highlight the most important concepts in robotics? Can you give us some examples?
When people start building robots, what they find a hard time understanding is that we as human beings do a lot of things unconsciously. When you program a machine to do it, it's not that trivial. Okay, for example, getting an awareness of your environment. Okay, and a robot, you'll have to add sensors to make it aware of what is going around it, and then use that information to act and perform an action based on it. So we perceive distances. We unconsciously perceive whether we're going straight. We unconsciously know how fast we are walking, and we can factor and adjust our walk to accommodate for all of that. If you're building a robot, then you're going to need a sensor to estimate how far things are. You're going to need to be able to control the motors to make sure you are going in a straight line. If you're following a path, a line, for example, you're going to need sensors to observe the difference in color to make sure that you stay on that line. If you want to control a robot via sound, the robot needs to, one, listen to that sound and then understand what that sound means. So that's where the challenge that most of the students think. They think, hey, I've put a sensor, it's going to work. Yes, it's going to work. It should work, but the sensor has a limitation. It's not like my senses.
So these projects force them to think about, in a very granular way, all of the things that are required that they may not have ever considered, that all of these things have to be taught to the robot. It's not intuitive. It's doing nothing by itself, and it forces them to look at it more practically. Is that right?
Yeah, that's a very good way of putting it. And also breaking it down into steps. Okay, so for example, the simple act of moving an arm up, we just do it. But for example, you have to activate the arm. You have to identify the direction in which it's going to move, how many degrees it's going to move, where to stop. Okay, so you've broken one step into 4 different steps. So you have to build the robot to have a motor to control the different pieces of the arm, and then program it to do each of those steps.
Have you seen some pretty cool ones?
Oh yeah, we generally have in the courses, we give them a theme. It's actually a specific task, because if you leave it very abstract, students then struggle on where to start, how to go. So we give them a specific task that your robot has to be able to, for example, walk this amount of distance, collect this many balls, or throw this many balls a specific distance. But that doesn't necessarily limit their creativity. We get so many diverse designs trying to do the one thing. And they have a lot of fun. In the end, we wind the course down with a competition. And so all the robots go head to head. Based on the challenge, and the kids have a lot of fun. They enjoy that.
If you're a student and this is something that you're interested in, what subjects should students be focusing on to ensure they are prepared for a career in this field?
The standard subjects that you would be doing if you are going to do engineering. So that's maths, the science subjects, physics, for example, would be very important. So nowadays, high schools actually offer opportunities for students to go into IT-related subjects. So if you can do a programming course, that would be useful.
It's interesting to me how so many of these areas of study overlap within robotics. It's, like you said, physics, mathematics, computers. It touches on lots of different areas.
Yeah, actually, robotics is what's called a multidisciplinary field. So we have people from electrical engineering, mechanical, computer science, chemical engineering, material science. They're all working together. Nowadays, a lot of universities have specific degrees in robotics, even at the undergraduate and graduate level.
Earlier in the show, we were talking about artificial intelligence, and you can imagine how that quickly gets into psychology and biology and understanding how people think. So it can quickly begin to expand into something extremely complicated. It's interesting to see how it starts and the basic core functions that you need to create a robot. Dr. Bina, is there anything I may have missed that you would like students or young children to know about the field of study, about robotics in general?
I think it's a field that will grow very rapidly. There are lots of opportunities. So if you are looking at options of what you might be interested in the future, this is definitely worth pursuing. And your lack of knowledge should not stop you from going out and exploring the field. Because as I said, there are kits around which are designed for people with no background knowledge. For example, the Lego kit that I mentioned, it's for years 10 and up. Okay, so it's designed for people who have no experience whatsoever with robotics. So don't let it stop. Just go out and buy the first kit you can.
It's excellent advice. Dr. Bina, thank you so much for joining us. We really appreciate your time.
My pleasure. It was lovely joining you.